I'm Anil Kumar, sharing with you a question from my subscriber. Let me thank him. So, thanks to Mr. Turab for posting these questions and having patience to wait for my solution. I actually wanted to provide a simple and understandable solution to this unique problem of birthdays. The question here is, in a group of 8 students, what is the probability that nobody has birthday on the same date, at least 2 have same birthday, exactly 2 have same birthday, exactly 3 have same birthday, 2 or 3 have same birthday, at most 3 have same birthday. So we have all kinds of combinations here with just 8 students to work with. So what I thought is that we can actually define a variable to deal with these different scenarios. So we'll say n is equals to 8, where 8 is number of students. So n is 8, that is, we are saying number of students. And then here we have same birth dates, 2 having same birth dates. So for that, let me define another variable x, where x is number of same birth dates. So x is number of same birth dates. Correct? So in the first case, when we say nobody has birthday on the same date, that means we are looking for probability when x is equal to 0, right? So x equals to 1 is also correct since everyone has unique birthdays. But I won't really confuse you by putting 1 here, but you could place 1. The second part is at least 2 have same birthday, right? So when we say at least 2 have same birthday, that means is probability for x could have more than, I should say more than 1. So that means all 8 could have the same date, right? So x could have 2, 3, 4, 5, 6, 7, all 8 people, right? So these are the cases, right? So as I said, x equals to 1 means same as x equals to 0. That means everybody has a unique date, no overlappings. That's what it means, correct? Now, if I say exactly 2 have same birthdays, that means probability for x is equals to 2. So that is a huge difference between these two scenarios, okay? So when we say exactly 3 have same birthdays, that means probability when x is equals to 3. And when we say 2 or 3, that means we're looking for union for x equals to 2, union x equals to 3, right? At most 3 have same birthday. At most 3 have same birthday means, well, none of them may have same birthday. So we are taking the case 0 or 1, as you may see, or 2 or 3, right? So all 3 values. So that is how we will actually define and understand our problem. And now we are going to solve it. So I hope this concept is absolutely clear, right? So we are working with 8 students and we're looking forward for them being unique birthdays, no overlappings, and then 2 same dates, 3 same dates and their combinations, correct? So let me solve them one by one. So the first one here is nobody has birthday on the same date, right? So that means let's do A part first. That means the probability when x is equals to 0. So nobody has on the same date. So in a year we have 365 days. So it should be 365 times next person will not have on that particular date, but the other 364 days. And then 363 and so on. So 8 of them, so it'd be like 358, right? So that makes 8 persons, all unique dates. Perfect. Divided by, since total number of outcomes are going to be 365 to the power of 8. So that becomes your answer for nobody has the same birthday, right? So we can just calculate this answer. It is, we'll start with 358, right? So we say 358 times 359 times 360 times 361 times 362 times 363 times 364 times 365, and whatever we get, we are going to divide by 365 to the power of 8, right? So we'll divide this by 365 to the power of 8, and what do we get? We get 0.92566, right? So that is 92.5%. Is that okay? So that's a huge number. 92.5% makes sense. So that means no birthdays will be overlapping in this small group of 8 students. Perfect. Now let's look into part B. Part B is at least 2 have same birthdays. So we have done the first one. So where x is equals to 0, some of you can say x equals to 1, all unique dates, right? D is at least 2, right? So that means not that condition. So that also means 1 minus P of not having unique dates, right? Not having unique dates. So that gives you the option, right? At least 2. So we could say this is probability for at least 2, right? At least 2 means probability of I should say 1 minus actually. Okay, let me do that. 1 minus probability for x equals to 0. That is 1 minus 0.92566. Is it okay? So that is it. So I have 0.9265. I'll just take away 1 from here and ignore the negative sign. We get 0.074335. So it is 7.4%. Not bad. So 7.4% is that at least 2 will have same date as their birthday. Correct? Now C part here is exactly 2 have same birthday. You should appreciate how they are different. Exactly 2 means only 2 persons have same date as their birthday. Correct? So the thing is, if one person has a date fixed, then the other person has the same date. So I'm just multiplying by 1. Do you see that? So the other person has the same date, and all others have different dates. So that means 364 times 363 times so on, 1 less than that. Perfect. 359. Correct? Divided by 365. These are total number of options for 8 people having birthdays. Now, it is important to understand that any 2 out of 8 could have that common birthday, right? Any 2 out of 8 could have this common birthday. Therefore, this should be multiplied by the combination 8C2. You get an idea, right? So that becomes the solution for exactly 2 people having the same birthdays. Am I clear there, right? So that is a huge step. Now with this step, you could actually answer part D, E, and F. So I'd like you to understand here and then answer D, E, F. Okay, so let's calculate this. Now if you see the difference between 0.9256 and this is that we have to divide by 358 and multiply by this, right? So I'll do easier calculation. 0.92566, we'll divide that by 358, right? So use your calculator, do your calculations, and then I'll multiply by 8C2. Perfect. So times 8C2, 8 combination 2, and what do I get? I get the solution for this as 0.07239, something like this. Okay, So that's what we get. So for exactly 2, it is slightly less than what we got earlier. It makes some sense, right? So that becomes the answer for exactly 2. And this is a convenient way of doing it. So I hope you appreciate the method, right? Now let's move forward. And so that is to say, I could write this as 7.2% if you want to write in percent, right? So let's move forward and answer part D, E, and F now. So now part D is exactly 3 have same birthday. Now when I say exactly 3, so we're doing part D now. Exactly 3 means probability when x is equals to 3. Now what will happen for exactly 3? So as you understand, from 8 we have a combination of any 3. This is one thing. Is it okay? We have a combination of any 3. Now if one person date is one out of those 365 days, then 2 others will also have the same date. Does make sense to you, right? And then, so that means we have involved 3 people here out of 8, 5 left, correct? So 5 left means they could have on 364 days, 363 days, and so on till 360, correct? So 60, 61, 60, 61, 62, 63, 64, 65 gives us 1, 2, 3, 4, 5, 6, and 2 have same dates as the first one. You get an idea, right? So that is the number to work with, divided by 365 to the power of 8, since there are 8 people. Does it make sense? Correct? So that is how you're going to find the solution for this one. All right? So let's figure it out. We have 8C3, 8C3 equals to times, we'll multiply from 360 to 365, 360 times 361 times 362 times 363 times 364 times 365, and then we are going to divide by 365 to the power of 8. So we get 4.0, so many 3's, 10 to the power of minus 4. Is it okay? So that is the probability for 3 persons having birthday on the same date. Okay, so that is what it is, right? So it is, you can say 0.000403, right? Something like this. Okay. So 1 and 2 and 3 and 4. So that becomes the solution for exactly 3. Now E is 2 or 3 have same birthday, right? So it is probability when x is equals to 2 or 3 means union x equals to 3, correct? So we have to combine what we did in part exactly 2 was part C, right? So exactly 2 was part C, so we can just combine those 2, right? So that is, we have to add our options for C plus D, correct? So previous 2. So you get for exactly 2 and exactly 3 as your solution, and F is at most 3 have the same birthdays, right? So at most 3 have the same birthday. It means what? It means that we are looking for a probability when x is less than equal to 3. Perfect. That means we are looking for a probability when x is equal to 0, x is equals to 2, and x is equals to 3. Is it okay? So it means all 3 of them. Correct? It means all 3 of them. So now you can combine our options, which were, no is option A for us. Is it okay? And then 2 and 3, we can say combine E, right? So combine E. So that is how you can actually get the solution of this kind of a problem. But I hope you understand the concept. It's very important to see that when you're talking about 2 or 3 people, we could select them from 8 And that's how we get the first part, combination. And then these are the dates when they could have birthdays. So I hope that becomes flexible enough to solve any birthday related question. Great. So let me again thank all my subscribers for posting such beautiful questions, that you have really made my YouTube channel a unique experience. I'm also learning with you, and I'm really enjoying the whole journey. Keep posting. And if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.